Well, good morning, everybody, and thank you for attending this morning's webcast on Map 3D 2009. Today's webcast is going to revolve around the 10 benefits that you get with using Map 3D over vanilla AutoCAD. So I'm going to go through a few PowerPoint slides here and talk to those just a little bit, and then we'll do some live demonstration. Actually, I've recorded some of the demonstration, and I'll just talk while that runs, and then we will entertain some questions at the end of the presentation. So here we're looking at the value chain, the geospatial value chain, and this is something that Autodesk has devised. You can think of it as kind of a barometer to determine where your organization is at in this value chain and where your organization can see the most benefit. This value chain is not meant to push people up from stage 1, for instance, to stage 5. What it's really meant to do is see where your data is in your organization and how that data can be best utilized, and in this value chain, where your organization best fits. So at stage 1, we're talking about AutoCAD drawings. All your information is in DWG, and that's good. DWG is a great design environment. But as you move up the value chain, your data becomes more valuable because it's accessible to more people in more formats. So as we move up to stage 2, you start to talk about Map 3D and what that adds to DWG, things like classification, drawing standards, drawing cleanup. And then up to stage 3, you start to talk about FDO, and with the FDO tools, that stands for Featured Data Objects, you have the ability to access many formats of data, and it's not really important at that point what format your data is in, whether it exists in a shapefile or a database of some sort or DWG. Map, using the FDO tools, is very good at accessing multiple sources of data. And again, up the value chain to stage 4, we start to talk about spatial databases and everything that a spatial database brings to your data, in that you're now spatially aware in that database, and a beauty of a database is that it's enterprise-wide. Many people can be working on that data via that database, and it really doesn't matter if they're using Map 3D or they're using another tool to access that database. Not everybody's interested, for instance, in the geography or the geometry in that spatial database. Some of the users may only be interested in the attribute information, for instance, assessors. And the information that they maintain is not necessarily geometry-based, but it's more attribute-based and parcel records and owners and values and things like that. And then finally, stage 5, that's the enterprise solution from Autodesk. It's called Topobase, and we won't talk too much to that today, so I'll just leave it at that. So here's a quick, nice graphical look at the Autodesk geospatial world. Let's break this down a little bit. So here on the left half of this donut, we have the desktop applications from Autodesk as far as geospatial is concerned, and that desktop application base is Map 3D. Now you'll notice there's a thin blue slice down at the bottom of that to let you know that Map 3D has all the functionality of AutoCAD, and on top of that AutoCAD functionality you get the Map 3D functionality. Again, another important thing to notice about this slide is that data is at the center. So we talked about this a little bit already. It doesn't really matter what format that data is in. Map 3D is very good at accessing that data. We build out the rest of the circle. On the right side, you see the web applications for geospatial in Autodesk. So that web application is called Mapgade Enterprise, and it is very good at distributing large amounts of geospatial data out to people via the internet. And those people, you can see, they might be maintenance crews, they might be individual users out there in your community. And around the center, again, is that thin blue ribbon of FDO access technology. That's the technology that allows Map3D and Autodesk Mapguide to access that data, whether that data is in a shapefile or an Oracle database or an SDF file, so on and so forth. And then on top of this base set of tools that you get with Map3D and with Mapguide Enterprise, we have all the verticals built on top of this. So you'll notice Civil 3D. So Civil 3D has all the functionality of AutoCAD as well as all the functionality of Map3D. Other applications that might sit on top of these, there are a host of enterprise applications that want to access this data as well. And then right at the top of the circle, you see TopoBase. And TopoBase has both a desktop application called the TopoBase Client, and it has a web application called TopoBase Web. And then the modules built for specific industries that can be customized to fit in your industry. So that's an overall look at the geospatial picture from Autodesk. So today's webcast, again, about the top 10 reasons why Map3D software should be used instead of AutoCAD. So here's the list, and I'll just hit some of the highlights here. Give designs real-world context. By that we mean you can now work in a real-world coordinate system. There are nearly 4,000 coordinate systems available through Map3D. So no longer are you working in an arbitrary XY location. You're now working in the real world, which in the geospatial world is very important because there are many sources of data out there, and those sources of data are going to be in many different geospatial formats, real-world coordinate systems. And MAP is very good at doing this coordinate system transformation to bring those together. So you might have a drawing that was done in a state planes coordinate system, and you've got a digital elevation model that you want to work with that's defined in a lat long. You can bring those together, and MAP is very good at that translation of coordinate systems. Streamlining data access, we saw with FDO technology that it's very easy to access data that exists out there in other formats, and we'll see that today in the live demonstration. Cleaner, more accurate designs. With Map3D you have the ability to build object classifications, so you can build real-world classifications inside of Map, and those classifications can be used to build a standard. For instance, for a water model, you might have a classification for pipes, for hydrants, for valves, and that standard then is then put together in that object classification and can be used by others in your organization so that everybody is drafting the same type of water pipe with the same layer and the same attribute information. So much more accurate. Powerful mapping and stylization. You'll see that when we start to use the FDO tools to access other sources of data, you can then use the stylization tools through Map3D to build out very nice thematic maps or stylize things in a certain way so that they accentuate one part of the data or another. Sophisticated database features. So we can actually build out a sophisticated database schema through Map3D using the schema editor, and we'll see that here in a minute. Rendering in 3D, if you have three-dimensional raster images like a digital elevation model or an Esri grid, you can take those elevation models and drape 2D information over it and make a nice 3D rendered model. We'll see that also. Simultaneous user access. So with Map3D, you actually have the ability to work in a true multi-user environment. Multiple people can be working in the same drawing at the same time, doing meaningful edits, making meaningful changes, unlike the AutoCAD world where the first person to open that drawing gets a read-write copy, everybody else gets a read-only copy. With Map3D, you can actually work in a multi-user environment. There's a metadata editor also, so it's important when working with spatial data that as things are changed or added, that metadata is kept up to date so that users of that data down the road have an idea of where the data came from, why things were changed, why things happened. And then finally, it's very easy to distribute what you do in Map 3D to the masses, and you can distribute through DWF, which is the drawing web format. You can also easily publish out to Mapgade, and we saw, if you remember back to the donut, Mapgade was a tool that we used to distribute much information out to the web. So, a quick overview of Map 3D. Some of the highlights here: direct access to not only CAD data, but GIS and raster data. So, again, Map is very good at accessing data regardless of what format it exists in. You've got all the AutoCAD tools for precision editing. You've got this huge CAD trained workforce out there. Why not give them the tools to make meaningful changes and edits and analysis in the GIS world? And that's exactly what Map does. So it gives you those AutoCAD tools and allows you to use those AutoCAD tools in the GIS world. It also adds a set of GIS functionality that allows very nice map creation, stylization, and analysis tools on GIS. Powerful, flexible, and open data management tools, so that those FDO tools are open. There's an open source technology available for use by anybody, actually. So those FDO tools are open and available, and they're great at managing many sources of data. And then finally, direct web publishing via Mapgade Enterprise, and it's really a one-button click. Once you put together your map environment, you click that Publish to Mapgade, and it actually builds a Mapgade site for you. So very powerful. So you've got some issues in your day-to-day that Map can help you solve. One of those issues is access to native data. So you've got a design, you've got a project coming up, you've got design data in CAD, you've got GIS information out there in many formats. You need to bring those together. The solution is work with those data sets in the format that they were originally developed. Irregardless of that format, you can work with those, again, typically through the FDO tools. So Map 3D is your solution there. You need the AutoCAD tools. You've got this CAD trained workforce out there that wants to work with the GIS data sets. So the solution, use those CAD tools, create and edit that spatial data. What's the solution? It's Map 3D and direct access via FDO using the CAD editing tools on geospatial data. It's coordinate geometry, it's drawing cleanup, it's the split and merge tools that allow you to work with that geospatial data and split and merge parcels, for instance. You need to create better designs. At this time, especially with the economy the way it is, you need to get more done with fewer resources. So the solution, again, provide that already trained engineering staff with some core GIS functionality that allows them to access, analyze, stylize CAD and GIS data together. Map 3D is a solution there as well. Publishing, you've got all this data, whether it's CAD data or GIS data, and you need to distribute it to the masses. So the solution, distribute geospatial data and maps in a variety of ways. And again, Map 3D is your tool. You can build map books. You can publish out to DWF files. You've got Mapgade Enterprise out there. And again, Mapgade Enterprise is also an open source technology. So there's a for purchase version. There's also an open source version that you can download and use for free. Map 3D continues to evolve. So here's a quick snapshot of the releases dating back to the 2005 release. Some of the latest and greatest achievements in Map 3D 2009 you see there at the bottom of the list. The ability to split and merge and put together rules that allow you to split and merge geospatial data. building in constraints into the attribute creation. So when you're creating spatial data like water pipes, for instance, you can build in constraints on that attribute creation so that users creating that data are constrained to certain attributes. For instance, a pipe material. You can constrain them to several types of pipe material rather than just being able to add any type of material they want. And then auto-population of attributes using calculated fields. So as you're working with this geospatial data, you can auto-populate attributes of that geospatial data based on calculated fields from the CAD side. So very powerful. So the beauty of Map 3D is that it truly brings CAD and GIS together. You get to leverage that CAD-trained workforce to manage geospatial data, thereby creating better designs and improving information sharing between the engineering and other departments. So let's take a look at the Show Me. So what I've done in this case is I've actually got some recorded hands-on things, and I will play those and I'll talk to them. And again, when we're done with the presentation, I'll open it up for questions and we'll entertain some questions here. So let's see, let's go ahead and start with the ability to add coordinate systems and work in the real world. So let me fire this up here. So the first thing we're going to do is we're going to set up a global coordinate system. So you'll notice that there are many categories here as far as coordinate systems go, and in each category there are many individual coordinate systems. So in this case we want to work in a California state plains. We know the coordinate, so we can type in the code and choose the Find button, and it will actually find that code for us. So there's a California state plains coordinate system. We'll apply that to the drawing. Now we can start to bring together other sources of data. So let's connect to some data here, and we'll see here are our FDO providers. We talked about FDO in the PowerPoint. Here's a list of those FDO providers. You can see the list there: ArcSVE, MySQL, ODBC connections, Oracle databases, raster images, SDF files, shape files, SQL, web feature services, web mapping services, all available through these FDO connections outside of the CAD environment. So let's go ahead and connect to a raster surface. Here we've got a digital elevation model. So we can connect to that data. You'll notice it's in a coordinate system different than the coordinate system we applied to the drawing. That's okay. Map can do that coordinate system transformation. So we'll add that digital elevation model to the map. Let's connect to another source of data. We've got another raster, and in this case the raster is in a folder, so we'll connect to a folder with a set of images. And in this case these are CID images, and these images are not 3D, they're just a typical raster image. We can edit their coordinate system. So again, apply a coordinate system to all of these images at once. They're in a state planes as well. And then we can use a couple of these images. And we can treat these images as one image and combine them onto one layer. Add those to the map. Let's see what we've got here. So there are those images, those 4 images we chose, kind of stitched together there. Another source of data. We've got a TIFF image. Let's go ahead and bring that in. Choose Connect. And you'll notice that the coordinate system is not specified for the TIFF image, so we can edit that as well. In this case, that image is in a California State Plains coordinate system, and it's the CATA. choose to add that to the map. So you can see how it's very easy to bring multiple sources of data together, and those data can exist in different coordinate systems. The map is very good at translating those coordinate systems so that everything comes together. Change the draw order here so that the larger image displays in back. Zoom up here in a particular area. See a very nice high resolution image from the CID. And we can track the coordinate systems now, and you'll notice that we're tracking the coordinate systems where our pointer is, and that coordinate system in this case is tracking in a lat long, which is different than the coordinate systems of the drawing or any of the images that we brought in. And we can change the coordinate system that the tracker is in. So let's set it to a UTM coordinate system. And now you'll notice that the X and Y of the tracker is different than it was with the lat long. It's also different than the X and Y of the actual drawing itself. So that's the ability to work with coordinate systems. Let's move on to the next, data access. So we can streamline data access, again, using the FDO tools, and we've seen that a little bit already. So let's connect. In this case, let's connect to a raster image. We've got the CID files. Make sure we pay attention to coordinate systems here. And set all those to a California State Plans coordinate system. And again, we have the ability to work with multiple images and stitch those images together and basically treat those images as one image. So that's what we'll do in this case. We selected a handful of images, combine them onto one layer of data. Let's connect to some other data. We've got a shapefile out there for the area, so let's get the water lines of shapefile. Connect to that. You'll notice it's in a state planes coordinate system for California. So there's the shapefile added directly to the drawing. And it's important to note that this shapefile, we're directly accessing the shapefile. This has not been a conversion or a translation into DWG information. We're actually directly accessing this shapefile. So you can see how the water lines lay on the image there. And we can look at the data table, and this is the actual attributes that define those water lines. So if we can select a water line in the drawing, and that water line is highlighted, that record is highlighted in the data table. Here's another water line highlighted in the data table. And you'll notice the real-world attributes that define those: type, size, whether or not that pipe is abandoned. So let's get a little bit more complex here. We've got a web mapping service. You'll notice that the URL we're going to connect to, so we're actually going directly out to the web and consuming information using an FDO provider from the web. So we can add to the map. The process is very similar whether you're accessing images or shapefiles, or in this case a website. So there you see the global mosaic that we've got from the internet. Zoom to its extents. Change the draw order, bring that down to the bottom so that the rest of our layers display on top of it. And we can zoom back to the extent of our water lines and see that global mosaic behind it. So let's talk about the next thing, which is going to be drawing cleanup. So Map gives you the ability to take a drawing and actually clean it up. So let's zoom up on a little area here. You'll notice in this case we've got water lines, and these water lines can have many errors in them as a result of drafting or digitizing rasters. So there are many ways that errors get introduced into a drawing. Map gives you the ability to clean up these drawings and make these drawings ready for the GIS world and the analysis that happens in the GIS world. So let's go ahead and start the cleanup tools, and we'll talk about those a little bit. So drawing cleanup is a wizard-based interface. The first page of this wizard, we build a selection set of objects that we want to clean up. So in this case, we want to select manually based on a layer. So we're looking at the AutoCAD layers. So on the water lines layer, we want to pick graphically all the water lines in this particular area. And these are the water lines we want to clean up. So on to the next page of the wizard. This is the cleanup actions page. On this page, we specify which cleanup actions we're going to perform on the selection set. So in this case, we've got 4 cleanup actions, and we can manipulate the order in which those cleanup actions happen. So first, we're going to break crossing objects, then we'll delete duplicates, then we'll erase short objects, and finally extend undershoots. And let's also make this interactive. On to the next page of the wizard. This also allows us, this cleanup tool also allows us to do a conversion. So we can convert lines to polylines, arcs to polylines, circles to polylines. Typically in the CAD environment, it's quite cumbersome to take those generic line entities and convert those into polylines. You need to use the pedit command. In this case, it's very easy to build a selection set and take those basic line entities and have them converted to polylines basically for free. So let's change our error marker size to be 10 so that it shows up a little bit better in the drawing. Everywhere it finds a particular error, it's going to mark it for us. So here's our cleanup errors dialog box. We found some crossing objects. We found 7 crossing objects. So if you highlight that, it zooms to the first crossing object, error 1 of 1. Let's change our zoom scale so that it zooms up a little bit closer. So there it found a crossing object. We can choose the fix button to fix that particular one, and it moves on to the next error. Error 2 of 7, error 3 of 7. By choosing the fix button, we just iterate through those errors. Once we've cleaned up all the crossing objects, we move on to the next error, which is undershoots. So we found 2 undershoots in this case, and again, we can iterate through those undershoots. Let's change the zoom size again so we zoom up just a little bit more. And again, using the fix button, we can iterate through those. Short line objects. So we found some short line objects. 3 short line objects. Again, we can iterate through those and fix those, or we can choose to skip them. So we've cleaned up, we've found all the errors that we specified. We've cleaned those up fairly easily. So again, much easier than trying to do those things manually in the CAD environment. Data standards. Data standards are huge in the CAD world. They're also huge in the GIS world. And Map brings those two together with something called object classification. So let's see, let's go ahead and start the object classification. So in this case, what we're looking at is we're looking at some generic CAD entities. In this case, they represent parcels. So let's take a look at the properties, and you'll notice that it's just a generic polyline. It's got no real-world data on it to define it as a parcel. So other than maybe a layer naming or some labeling, there's no real-world data to define that as a parcel. And this can exist as a polyline or a line. But what we can do is we can build an object classification to say, hey, that when we create a parcel, that parcel exists on a particular layer, it's always a polyline, it's always closed, and it's got these real-world attributes. So let's see how we'll do that. So in the task pane, you notice that we've got some object classes built, and there's one for parcels. So we can use that object class to classify objects that exist in the drawing. So I'm going to now select all these parcels in the drawing and classify those. You'll notice that they changed color. Why do they change color? Because the layer that they exist on has now changed. So if we jump back to properties, you'll notice now that they're on a new layer, a layer called parcels, which in this case is green. And they've also got real-world attributes through the object class. So you'll notice now we're tracking things like address, parcel number, land values, and street names, things that weren't there in the generic CAD world. So let's do the same thing with some water pipes. So we'll turn on the water pipes layer. You'll notice that they're black. I've got a water lines classification, so I can classify objects. In this case, I'll just use a window to select those objects. You'll notice it selected some parcels, but that's okay because objects that are already classified, like these parcels are going to be excluded from this selection set. So again, you'll notice that the colors changed. The color changed because of the layer change. We want all our water lines to end up on a water layer. And now we're tracking real-world data. We've applied that to each of these objects for whether or not the pipe's abandoned. We've got a feature ID, a size, and a pipe type. With these object classifications, we also have the ability to create new objects. So rather than starting the polyline command, making sure I'm on the correct layer, and then adding all these real-world attributes after the fact, I just go ahead and choose Create Classified Object from the object classification. And now I'm drafting with all those parameters already set up for me. So as I complete this water line, you'll notice it turns blue. It's on the right layer, even though the right layer wasn't set. And it's also got all this attribution, this object class, object data for free. So that's the beauty of, and also the ability to apply standards via object classification. So the next thing we want to talk about is the ability to build display maps. So we can bring together multiple sources of data, like you'll see we've got here. We've already accessed some FDO data. We've got some flood zones, we've got some parcels, and we've got some CID images all laying together here in this map. And we can now begin to stylize this data and build themes. For instance, we can theme based on land value. And choose a distribution type, choose a theming range of colors. Add some transparency to these solids so that we can see through them. We can also build labels. So we can build labels from that attribute data. We'll label the land value and manipulate its size. So there is our theme, ranging from a yellow color to a green. You'll notice now that our parcels are themed based on the value of their land. We've got a different map here that specifies zoning. This zoning map has already been themed to show different zone values and labeled as well. We've got an environmental map, so you can see that it's very easy in Map 3D to build multiple maps in the same drawing, and those maps can show, accentuate different things. So in this case, we're looking at an environmental map. It's doing some slope analysis for us. So you see slopes highlighted in the steeper the slope, yellow and then orange. So let's talk about now database creation. So we talked a little bit about this during the PowerPoint. We have the ability to create a database. Directly through the Map Explorer, we can build a new schema, creating either a shapefile or an SDF file. In this case, let's create an SDF file. We'll give it a name. Let's call it water lines. And we'll delete the default schema we get because we want to import a schema. And you see that schema imported here. It comes in with a geometry field. We've got an auto-generated number to keep track of the pipes. We can edit all this data, so let's go ahead and edit the name for auto-generated. We've got an abandoned field. And what's nice here is we can specify first the length of the string, and we want abandoned yes or no, so a length of 3 will work. And then we can build a constraint so that users only have the ability to choose from this list that we build. So are the pipes constrained? We can have yes, we can have no. So that's the list that users can choose from. The pipe size, let's make this size not a string data type, let's make it an integer. So we'll use the int16, and then finally pipe type, a string, and give it a length. How many characters can these strings be? So they can be up to 10 characters long. So we've built out a database schema that we can now use. So we get a warning that says this schema is empty. Okay, we know that. We just built it. We expect it to be empty. But now it's available to us here through our display manager. There's that waterline schema. And we can now begin to create features inside of that database. So we can create a new line string for that waterlines feature class. Using our typical CAD tools, we're just going to draft a waterline now. And let's use some of the Kogo tools to specify the bearing and the endpoint. So there we've just created a waterline in this SDF repository. You'll see there the abandoned field where we can choose either yes or no, put in a size, as long as it's an integer it's okay, a pipe type, PVC in this case, and once we're done with that we can check that waterline in, and it updates the database with that new feature. So if we look at the table, we see there is our first waterline built into this database that we just created. The ability to render in 3D. So we've got three-dimensional rendering capabilities with Map. Here you see we're connected already to a digital elevation model, which is a 3D surface, three-dimensional raster surface. We're also connected to a two-dimensional USGS quad sheet. So what we're going to be able to do is first stylize that digital elevation model, and we'll put a new theme on it. We've got a bunch of predefined themes. So here we're using the USGS digital elevation model palette. We can apply that to our 3D surface. You'll notice that it stylizes based on height, different colors. We can drape this USGS quad, this two-dimensional raster, over the three-dimensional. Make sure we get the draw order right, and then when we move into 3D, you will see that two-dimensional surface draped over that three-dimensional raster. You can spin it around here and get different looks at that data. Let's zoom up on an area here. What we can do now is we can take that three-dimensional raster and we can create a contour layer from it. So we can build a three-dimensional contour layer. In this case, we'll have contour intervals at 100. And you'll see that contour layer show up. There it is. And that contour layer was built directly from the raster image. Let's make it a little easier to see that. Let's turn off the USGS quad. And so there we see just a digital elevation model, stylized based on the USGS palette, and contours showing on top of it. And those contours are a separate file. So the next thing we'll talk about is the ability to work in a true multi-user environment. So Map 3D gives you the ability, you'll notice here that we're in a particular drawing. Let's generate a query, which is a request from information. You'll notice that we're connected here to a drawing called City Parcels. We're going to request some information from that City Parcels drawing and make it part of this current drawing, which is called Session 1. So let's go ahead and execute that. We see a grid of data here. Let's change our view. So let me zoom up on that a little bit better. So there's that one particular grid of data that we requested from that other drawing. So let me open a second drawing here called Session 2. You'll notice we've got the same grid in Session 2, although it's a separate drawing. We're connected to the same City Parcels drawing. So two different users connecting to the same drawing, accessing the same query, requesting the same information. So there's that grid of data. And we can zoom up on that using a named view. At this point, both user 1 and user 2 have read-write access to this data. Here's a split look at the two sources of data, two different drawings. Again, looking at the same drawing. Zoom to a little different area here. We're looking at some parcels. And then I'll get the same view here in this other drawing. So we're looking at the same sets of parcels here. So if I take one of these parcels and I make a change, perhaps to the color, you'll notice right away that we're prompted to add objects to the save set. The save set is the intermediary between this drawing we're working in and the City Parcels drawing this information originally came from. So we can add that information to the save set. Let's change the land value here. So the land value for that particular parcel is being changed. The net value is also changing. So back to the other drawing, we'll select that same set of data, that same parcel. We take a look. It's on a different layer at this point because this change is only in the save set right now. If I try and make a change to this and add it to my save set, I get a warning. I can't add this object to my save set in session 1 or session 2 because session 1 has already manipulated that particular object. So in this case, we're working a true multi-user environment, locking objects at the object level, not at the drawing level. It's telling me that it's locked by which user at what time. So I can go to that user and say, hey, you need to clear your save set because I need to work on this data, this particular parcel. So in this case, user in session 1 goes to their save set and saves it back to the source drawing. And you'll notice as soon as that happens, it disappears from this current drawing it was in. I can re-execute the query to get that back. And you'll notice now that it has been changed. It is the cyan color that we specified. Its land value is different. But here in session 2, we're still seeing what we originally got. Now in session 2, how do we see those changes? What we need to do is go to the task pane and re-execute that query. So as soon as I re-query that, now I see the changes that were made in session 1 is no longer locked now because the save set's been cleared. So what I can do is I can now make changes to that in session 2 if I choose. So again, a true multi-user environment, multiple users accessing the exact same data and working at the object level. And finally, the last thing we'll talk about is the ability to publish this data to Mapgade. So we're looking at a fairly complex map that we've put together here in Map 3D. We've done some theming, some stylizing of zoning areas and parcels. We've done some labeling, and this map looks pretty good. We want to share this map via a Mapgade Enterprise website. And you notice we clicked one button there that said Publish to Mapgade Enterprise. We're now connecting directly to a Mapgade website, a Mapgade server. We're logging into that server to be able to publish information to it. We can create a new folder to put this data in, call it zoning, and choose the publish button and let it work. And it's actually creating a Mapgade website from this data we have in our Map 3D interface. So it published our data successfully. Let's log into our Mapgade Studio. We can actually see that newly published data through Mapgade Studio. Mapgade Studio is an authoring environment for Mapgade websites. So give this a moment to refresh here, and there is our data, again, all put together in Map 3D and easily published out to a Mapgade website. Zoom into some of this data here. You can toggle layers of data on and off very easily. So you've got all the functionality you would expect through a Mapgade website, again, easily built using one click from Autodesk Map. So those are the 10 reasons, top 10 reasons that Map 3D is a pretty big enhancement over AutoCAD or vanilla AutoCAD. So I'm going to go ahead and unmute the phones now, and we will entertain some questions. Are there any questions out there?